Okay, so we have kinetic energy is 1/2 mv squared, kind of a principle. It derives from other principles. But, and you should know how it's derived. For constant force, how do you derive this? We did it for homework. And we did it in class. And then you have the general definition of work as an integral of the dot product of your force and your displacement. Okay? Now we're not doing line integrals. No, we're actually not doing them at all in this course. Okay? Even though some of you are doing multivariable calculus would understand it. It's beyond the scope of the course. Okay? But in one dimension, what this means is F and delta S are now directed along some straight line, right? Okay? And each is either positive or negative depending on which direction along the line. Could be either that you choose as positive, right? And the line could be horizontal or vertical, or it could be any angle. Okay, but as long as you're along a line and do the F and the delta S with plus and minus signs after having chosen your positive direction and documented that, then you're okay. I'll also say that work is F perpendicular times your delta S in one dimension, which takes care of your dot product if you're in one dimension. And it's, yeah, I hope I haven't been writing F perpendicular. It's F parallel times delta S. F perpendicular does no work. Okay? And you know, kind of remember kind of writing that down without thinking. So if I ever wrote F perpendicular times delta S, expose me for a fraud. Okay? Because that was really pretty bad. But it's F parallel times delta S. I might be confusing with something I wrote down in multivariable calculus where we do deal with F perpendicular. The component of the force parallel to your direction of motion times your displacement, right? Again, you could have both positive, both negative, one positive, one negative. Your work could be positive or negative.